we need to know the 6 important functions. The average cost functions ACX equals the cost function divided by x, and it means an average value of the cost function. Similarly, we can get the average revenue function ARX equals the Rx divided by x. And as for the profit function, Px equals the revenue minus cost, Rx minus Cx, and we can get the average profit function APX equals Px divided by x. Now some new concepts about the derivatives application of derivatives. Firstly, the marginal cost. It equals C prime x, and it incurred the additional cost incurred when producing one extra unit. The C prime x is a derivative of the cost function, representing how cost change with production. R prime x is a derivative of the revenue function, showing how revenue changes with sales. And then for the marginal profit, similarly, it's the prime of the profit function, and it equals R prime x minus C prime x. This shows how profit changes by balancing additional revenue and additional cost. To get a better understanding, I give 3 simple examples, and let's see the meanings. For the first, the marginal cost. The marginal cost function equals 50 here, and meaning producing one more unit always increases cost by 50. And for the revenue function, Rx equals 100x, and its derivative is 100. So marginal revenue is constant at 100, meaning each additional unit sold generates 100 in revenue. And for the profit function, we get the P prime x equals 50, meaning each additional unit sold adds 50 to profit. Let's look at some example analysis.
Okay, let's see this example. For the first question, Cx equals 10x plus 5,000 for the cost function of the XMUM cafeteria. And we will find the marginal cost. Then the marginal cost equals C prime x, the derivative of the Cx, and it is 10. It means when we add one food, then the cost will add 10. For the second question, the additional cost equals the quantity times the MC, and the additional cost equals marginal cost times and equals 200 RM. That the revenue function is 50x and the cost function is 30x plus 2000. So we know that the profit equals the revenue minus the cost, and it equals 20x minus 2000. And if there are 100 person, we know that the total profit equals 20 times 150 minus 2000 equals 1000. Let's see this example. We know that X is the number of drinks sold per day, P is the price of each drink, and X equals 100 minus 5P. For the first question, we need to write down the marginal revenue and determine the price that maximizes revenue. We know that marginal revenue equals R prime P and equals 100 minus 10P. If we want the max, and then the MR equals 0, and we can know that P equals 10. And this is question A. For question B, we can know that the maximum revenue when the price is RM10, that equals R10. We just take it into the function 100 times 10 minus 5 square of 10 equals 500, and we know the maximum revenue is 500 RM. So the question is done.
Part 2. The Washer method for volume. The Washer method is a calculus technique used to calculate the volume of a solid of revolution. And the idea is we get to know the outer radius and the inner radius, and then we can obtain the areas of the individual circular rings of this. We can see here the rings, and then we sum them up and we get the volume. Let's see the formula. The volume equals pi integral from a to b, the square of big Rx minus the square of small x dx, and the big Rx is outer radius, distance from the axis of rotation to the outer curve, and the small x is the inner radius, distance from the axis of rotation to the inner curve, and the from interval a to b is the range of the region along the axis. Now it comes to an example.
Let's see this problem. Firstly, we sketch it. The first curve is root of x. It looks like this. And we know that when x equals 1, y equals 1. And it is the same as for the y equals x, the second curve. Yes? And we need to find the volume of the solid formed when the region between the two curves over the interval 0 to 1 is rotated about the x-axis. And that area is this area. We need to find the outer R and the inner R first. The big R x equals the root of x, and the small x equals x. And then we use the formula. The volume equals pi interval 0 to 1, the square of the outer R minus the square of the inner R, and then we can get it equals to now we can do like this, separate it. I found its original function. It's and plus, yeah, pi over 6, and the final answer, the volume equals pi over 6.
Part 3. Moments and the center of mass. The moment definition is that moment is a measure of the rotational effect produced by a force around a specific point or axis. The magnitude of the moment depends on two factors: the size of the applied force and the distance from the points of rotation. Level on. We can get the formula. The m equals integral x times rho x dx. The x is distance from the reference point, and rho x is mass density function. About the center of mass. The center of mass is a point of balance of an object representing the average position of all its mass. And it has many situations. For the 1D center of mass, the function is x bar equals my divided by m. And for the 2D situation, the x bar equals my divided by m, and the y bar equals mx divided by m. Now comes to some problem solution.
This problem, at first, we know the length of the banner is L, and the mass of the banner is M. And the banner are suspended by the two ends of the banner are suspended by supports, and then we will calculate the position of the center of mass of the banner. We just use the formula, the x bar equals 1 over m integral 0 to L x rho dx, and we know that rho equals m over L here. And then we take this to rho. We can get x bar equals 1 over L integral 0 to L x dx equals so we know that x bar equals 1 over L times the square of L over 2. It equals L over 2. And now we will calculate to get the moment about the support point. First, F equals mg, and the moment equals F times d, because d equals over d equals L over 2, and we know m equals and this m is mass. Okay, maybe we can write moment. So we get it. The position is L over 2, and the moment is 1 over 2 mgl.
Okay, that's all. Today we talk about the application of calculus in economy, and we use the washer method to get the volume, and we get to know the center of mass and the moment. And we know that the calculus have many applications in the science and technology and in our life. So learning calculus is very important. Finally, thank you very much. Thank you for listening.